In this section, we'll be talking about the fundamentals of sets and basically going over what it is to be a set and some of the general properties of a set. So diving right in, the first question that we want to ask is, what is a set? And ultimately, a set is just a collection of objects. For instance, that could be a collection that is just the numbers 1, 2, 3, and 4. Maybe it's a collection of letters instead, where we say that the set X is just equal to A, B, C, and D. Again, it's just a collection of objects. It could be a collection of U.S. coins, such as pennies, nickels, and dimes. One of the things about sets is that elements have to be unique. So, for instance, this example here where we have a 1 and then a 2 and then another 2, and then a 3 and then 3 4s after that is really not a valid set because those 4s are repeated and the 2s are repeated. What would be a valid set, again, is just that 1, 2, 3, and 4 where each element only appears once. Again, just saying that all elements have to be unique. Now, as we make it to larger sets where it's really just more elements than we want to write out, if we can come up with a rule, then we can use what's called membership properties for large sets. A membership property is ultimately just a definition, a condition that allows an element to be part of that set. So for instance, here we have the set B is equal to all numbers n, where n is just a positive integer. So this is every positive integer like 2 and 7 and 12 and 15 that are all part of the set B. Now, we're going to do a quick review of some common sets, which hopefully you're familiar with. But just to work through those real quick, the first set we'll look at is the set Z. And Z is just the collection of all integers. After that, we have Z plus, which is the collection of all positive integers, and Z minus, which is the collection of all negative integers. We also have the set Q, which is the collection of all rational numbers, Q plus, which is all positive rational numbers, and Q minus, which is all negative rational numbers. And then the other three sets we'll look at are those of real numbers, which are R, R plus, and R minus for the set of real numbers, of positive real numbers, and negative real numbers, respectively. Now, again, this is a review. You probably won't see these come up too much, but it is good to have these on a cheat sheet floating around somewhere that you can reference if you ever see these in future homework problems. Now, talking about some of the elements and properties of a set, there's some general terms that we'll use to describe information about a set. The first one we'll look at is what's called the cardinality of a set. And the cardinality of a set we notate very similar to absolute value, just with vertical lines around each side of the name of the set, as you can see here. And the cardinality of the set is just the number of elements in that set. So if we have a set X that is comprised of A, B, and C, then the cardinality of that set, we would say, is just equal to 3. Now, the other thing that we'll look at is more properties of sets. And again, we'll say that we have an element A. And if that element A is in the set X, then we can write that A is an element of X. Again, this operator here just being the element of operator. It's saying that this A is part of X. So in this case, X might be the collection A, C, and E. Now, the other operator that we'll look at is the not an element of, and it's the same operator as element of, just with a slash through it. And so we'll say that if the element A is not in the set X, then A is not an element of X. In this case, we would look at a set that is X equal to maybe B and D, but the important thing being that it does not have A in it. Now, finally, we'll look at what's called the empty set or null set, and this is just denoted by a 0 with a line through it. And this is a set that has nothing in it. So we would say that the empty set you'll also see written as just empty brackets. It's a set with nothing inside of it. Again, it's also called the null set. Now, the next thing we'll look at is what we call the equality of sets, and this is saying, are sets equal? And ultimately, sets are equal if they contain the same elements. And so what we'll say is that a set X is equal to a set Y if and only if for every element X, if that element is part of the set X, then that element must also be part of the set Y, and that for every element, if the element is part of the set Y, then it must be part of the set X. So this is bidirectional equality. So if we have a set X that we say is equal to A, B, and C, and a set Y that is just equal to A, B, C, and D, well, in this case, the A's, we can look at X and say that there is an A, a B, and a C and Y. So it's equal in this first direction. But when we look the other way, we'll see that D has no matching element. And so in this case, X is not equal to Y. And if you notice, unequal sets are denoted as X not equal to Y. Equal sets are just denoted as X equal to Y. Now, looking at subsets of sets, we can say that a set X is a subset of the set Y as long as for every element, if that element is part of the set X, then that element also has to be part of the set Y. And this is half of what we just looked at for equality. So if we go back to that same example where we have an X that is equal to A, B, and C, and a Y that is equal to A, B, C, and D, then we can look at this and say that for the set X, that there is an A, a B, and a C represented. So we have met this condition, and therefore X is a subset of Y. Now you'll notice that there's this line underneath this operator, and there's a reason for that. This is actually is a subset of or is equal to Y. And this is a generalized definition of subset. A subset can actually be equal to the set of which it is a subset, which is a little bit confusing. So the term that we use to say that it's purely a subset or that it is a subset and not equal to is this thing called a proper subset. And a proper subset is where X is a subset of Y, but X does not equal Y. And in this case, we'll just denote it as X is a subset of Y. So in this case, because X is missing the D, it is not equal to Y. We already said that it is a subset of Y. And so in this case, we actually do have a situation where X is not just a subset, but X is a proper subset of Y. The set of all of the possible subsets of X is what we call the power set of X. And this is denoted as P of X. It's not the same thing as the probability. You'll notice that this is actually a script P versus just a regular P. And we aren't going to spend a whole lot of time with power sets. So within this course, anytime that you just see P of X, you can generally assume that it's going to be a probability. But again, this is something you'll want to be aware of potentially for future courses depending on what you are studying.